Hey, we're live. Welcome to another physics video. I thought I would, I had a couple minutes. I thought I would record another quick video example of right-hand rule number 2, because I know when we are together in real life, that always drives you guys crazy. So, right-hand rule number 2, do another example, and hopefully that will help you all. So, I'm going to try and color code it so you can see a little bit better. And so we're going to do a black vector for velocity. And let's see, let's do green for magnetic field. And then we'll do blue for force. So let's start out. We can probably honestly do a couple of these. We're not going to do the math. We'll just talk about the directionality of everything while using the right-hand rule. And nobody took me up on my offer to do a lecture about linear algebra and cross multiplication. I'm so surprised by that. I would have thought that would have been a super popular option for you guys. But anyway, nobody did. So we'll just have to keep using the right-hand rule and make believe. But anyway, let's say we've got a magnetic field that's going into the page. So into the page, uniform magnetic field, I'm going to draw that with a bunch of X's to represent that I have vectors that are going into the page. So they're coming from you and going into the page, perpendicular to the plane of the whiteboard. That's important. We never did talk about what happens if things are not perfectly perpendicular, and I'm not sure if we will. Well, eventually, maybe. Anyway, let's say that that's our magnetic field going into the page. Uniform magnetic field. Now let's say that we've got a proton, so a charged positive particle, little proton there, and let's say that it has a velocity that is going straight upwards, or to the north. Straight upwards is its velocity. Boom, like so. And then the question that we'll ask would be, which direction will the force on that particle be? So pause the video now if you want to try and figure it out for yourself. Just remember, thumb is always the direction of the velocity. Fingers, if you hold them at a right angle and make a little finger gun, fingers are always the direction of the magnetic field. And then using your right hand, and provided that it is a positive charge, if it's a negative charge, it's just reversed. You still use the right-hand rule, it's just when you get the answer, you just flip it over 180 degrees because it's a negative charge. Opposite sign, opposite direction. But anyway, the force is the direction that your palm would point. So right now my palm is pointing straight up to the roof. Right now my palm is pointing straight down. Right now my palm is pointing straight, what I would consider to the right, or straight to the left. So that's the direction that my palm points in. And so hopefully you've had enough time to think about it, or pause the video by now, and I can say, all right, velocity, thumb going upwards. Fingers, magnetic field are going into the page. And so with that being said, which direction does my palm point? My palm points to the left, and that is the direction that this proton will experience a force, to the left. Which means the path this proton will actually take will create a circle. As long as it stays inside this uniform magnetic field, this charge will start to create a circular path around and around and around. That's pretty neat. I think we have time for one more, so let's do one more. Let's give you a negative charge this time. Let's say that the magnetic field is going straight across from left to right. Uniform magnetic field. This time let's say that we have a negatively charged particle. Maybe it's an electron, maybe it's just a mote of dust with a negative charge on it. And let's say that its direction is actually into the page. So I don't know how I would draw that. Yes, I do. I would just say that its direction, I'm going to use a dotted line to show it, kind of going into the page. And I'll make a little note, into, just so that we know that the velocity of that particle is going into the page. And then I've got all I need to tell you what direction is the force on that electron. So use the right-hand rule. Pause the video now if you need to. Do it, seriously. Try and figure it out for yourself. Which direction is the force on that electron? Okay, you've paused the video, you're back. Did you say down? If you said down, you used the right-hand rule correctly, but you forgot that you have to flip it if it's negative. So if this was a positive charge, our thumb would be going into the page. I'm trying to figure out how to make the camera angles work. Our thumb would be going into the page. Where is it? There it is, right there. And our fingers would be pointing straight out in the direction of the magnetic field, which means that the force vector would be from my palm going down the page. Well, that's wonderful if it were a proton. But it's a negative charge, it's an electron, so you have to flip your answer just 180 degrees in the same direction, which means really the force is going to be up. So if it were a proton, it should have been down, but it's an electron, so the force on this particle will be up. If you said up, congratulations, you understand right-hand rule number 2. Which I will tell you guys is actually not that easy to get a hang of. It's actually extremely easy to get a hang of if you practice it enough. You really do have to practice it. It just won't click unless you practice. So I hope that helped. We will talk tomorrow and answer any questions that you guys have. There's really only the one hard question on the study guide that I sent as your homework packet. The rest of them are pretty straightforward. I have complete confidence that you guys can do them. And when we talk tomorrow, we'll talk about that difficult question. I hope you guys have a great day. Stay healthy, stay busy, keep your mind working, keep your body healthy, stay safe, and I will talk to you guys soon.